right, the evening edition. Hopefully this all works, which is, I always say it looks right, and then I screw something up when I'm streaming. Yeah, this is from River. This is River Nation, so I'm streaming. So hopefully they keep their stream up. And I put the link in there. So the music is thanks to River and thanks to River Nation. All right, so I'm going to pick up where I left off this afternoon, which was me trying to do these assign distance functions rendering, and it's all copy paste code. I'm just porting some stuff over to Go from Python, but I'm trying to understand why it works as I'm doing it, and my animation's not working smooth. So I don't know, maybe an hour here, maybe a little longer. It's only 9 o'clock. Only, he says, only 9 o'clock. And I do have a LaCroix, as always. So, my favorite, a tangerine LaCroix here. So, I'll drink some tangerine LaCroix, and, I don't know. I think we'll switch things over to use Go's. Like right now, I'm just doing a sleep in a loop, and I think we'll switch things over to use Go's ticker, which is the right way to do it. So that's where we'll start. Get going here. All right, this is what we're going for. 30 frames a second, something like that. Nice, smooth animation. And here's what we have. Something not right. Not what I want, for sure. And I did double check it. It's the same problem in both terminals, so it's not a commander issue. So let's get the terminal out of the way here, and let's get rid of this loop. So I have this draw function. So I have a main function, program enters, and we call draw, and the draw routine has a loop in it, and I think what I want to do is get rid of the loop, and we're going to call draw on a ticker. So we'll let the draw routine just draw one time. So we're going to get rid of this loop. We are going to get rid of this sleep. And now when we run the program, let's actually get a terminal up here. Move you. And you need to go to editor so we have a bigger view here. So now when we run it, it's just going to draw and exit. So that's good. So let's, I don't know. I have this weird thing where I like to keep my main functions empty or close to empty. I don't know why. I feel like it needs to be better named. I don't know. So let's just have a run function. This is like pointless for my toy code. Not like it really matters, but this run function, it can actually even be called start. We may change it to start, but run is where we'll deal with the ticker. That's pretty cool. Funky. I'm going to pull that down just a little bit. Yeah, I'm totally going to get distracted by this music the whole time too, because there's a bunch of stuff in here I had never heard. All right. Start a ticker. We'll draw on tick. All right, so right now this should be the same exact thing if we run it. It just runs and exits. Let's go here. I never remember how to use ticker. I love Go by Example is the greatest website for Go stuff. All right, so we make a ticker, we make a done channel. Why is it copying the text? I don't want the text, I just want the code. That actually copied. Hey, it did. All right. Okay, so when we're done, we will return. Otherwise, we're going to draw. And this is going to tick at 500 milliseconds. And I was just doing this a second ago where I was struggling, or on the earlier stream where I was like, how many frames a second do I want to run at? What is that converted to milliseconds? So 1,000 divided by 30 to write that out. 1,000 milliseconds a second divided by 30, just so we have the math sitting there in front of us. So that should be 30 frames a second if I'm not too sleepy. And this done stuff doesn't really matter. I'm not going to stop the ticker. What I do want to do put true into that done channel. I just want to wait. Does ticker have a wait? No. Stop. Yeah, let's just let it run for 3 minutes. All right. So now this should be running, doing a thing. But it's still so slow. That should not be the case at all. Alright. I'm gonna go get my Space Invaders code. This is when future me thanks past me for just doing all this in one file. Just be copied and pasted around. Mad because they're in the same thing. Yeah. Just like main dude. Tidy. All right, this is updating just fine. Minus my little flickers that are going on there. Yeah, that's, I mean, moving my little spaceship's pretty smooth too. Something else going on. So Invader Go, I have a lot of helpers in here, but I'm doing the same sort of thing, clearing the screen. Since CSI, what I'm doing. Escape code. I mean, I don't think it matters. I was using this. Try to change this. Of course, it's all in package main. We have access to all this now that I pasted that in. Bob Ross, happy accident. So we could use that my screen update code. Yeah, that just shouldn't be that slow like that. So what can we take away just to test what's going on? I mean, this is super slow, but I mean, Go's still fast, but we shouldn't be doing this. We shouldn't be appending like this. So I'm 20 by 80, but I'm putting a new line in there. So really, I'm 21 by 80. Why can I not do this in my head? 21 by 80, 168. Wait, 20 times 80. 1600? I don't know. It doesn't matter. 1680. Not 168. 1680. Okay. Maybe I am tired. Take this, I put this in here, so now I have an array instead of a slice, so it's at 1680. I go ahead and do all this, and then I'm not going to append anymore. So this is going to be frame characters. Let's think about that. I need to know how far into that array I went. So 0, 0, top left. I'm imagining that laid out. And then I iterate through, I'm at 0, 1. So what does that offset look like? 0, 0, 0, 1, that's all fine. Then I have to start multiplying 80 by Y. So frame characters 80 times Y, which is 0 the first time through, then 80 plus X equals sample. So once I get down here, what information do I need to know? Anything? Or is it just 80 times Y? Is that going to be weird? That it's... Because it's not 80, it's 81. Right? Is it 81? I always trip myself up thinking about moving through an array like that. It's going to start at 0. Let's just say it was a simpler matrix. So we just have 1, 2, 3. Well, we should use 0. 0, 1, 2, 4. 5, 6, 7, 8, 9. So this is 0, 2. So if I did 5 times 2 is 10 plus Y. feel like something's gonna get messed up here. Like I'm not taking into account the correct extra spot for that 81st thing. Because if this were 4 instead of 5, it would loop through here, and then it would add this, and then it would go 4 times 1 is 4, and it needs to be plus 1, and then it needs to be plus 2, so it needs to add the row. It's times y plus x plus y. And then I can do y. So wherever I'm at, times 80 plus 1, or just times 81. I don't know, it's a hot mess, we'll find out. Ooh. Interesting. So I made an array. Now what happens if I just make it a slice? This seems kind of ridiculous though. You just slice the array. It's handy. Okay, makes sense. I feel like I'm gonna have a major off by 1 error in here though. It's all skewed. Oh man. But that does rule out, that's not the problem. String joins not that slow. Get that plus 1 out there. Let's do this. This is a great time to explore Go's profiling tools, which it has great profiling tools. I don't remember how to use them all. Let's see how far we get with just pprof in here. Hey, Julia's got a thing on that. Her. I don't want a heap profile. I want stack traces. All right, so we're going to make a temporary file. SDF prof. Here, handling committed. Sure, that's fine. For stop CP profile. Okay, so that runs. Let's run this. Actually, let's just have it make the file right where it's at. Loops in there, and then we want to read go tool. Empty. That's not good. I guess the problem is I need to catch that interrupt. Or just let this run for, or just let this run for 10 seconds. That's the problem, the interrupt, I think, is causing it to not write. Hey, there we go. Much better. There should be a bunch of junk in there. Great. A flame graph. interesting that these are both pearl scripts to convert this. All right. Stack collapse. And flame graph. Here's another question. Do I even have pearl? Yes. All right. P-Prof, raw output. Right. Stack collapse. CPU. Flame graph. Preview? I could have sworn there was a thing to preview this. Math.pal and time.now are slow. Time.now is slow.
Seems to be about her life. Every line gets closer to the sad part, and every word seems to be about her life. Isn't meant to very soon to the sad part. To the sad part. The sad part. Isn't meant to very soon. She was always happy. Isn't meant to very soon.
Yeah, obvious, right? X times X instead of squaring it. Yeah. See the forest for the trees. All right, well, let's start there.
Every word seems to be about her life.
It's always the obvious
Every line
stuff.
gets closer to the sad part. And every word seems to be about her life. Isn't it too fast to the sad part? To the sad part. To the sad part. Isn't meant to favorite songs. She was always happy. Isn't meant to favorite songs. She was always happy.
All right, great. All right, that gets rid of Math Bot Pow. Man, it's still running slow. Okay. Oh, I control C'd it. I didn't let it run. Let it run until it quits. I don't know a way around cosine and sine. I mean, short of using cosine is so. I don't know a way around that. Short of like trying to go to the GPU. But time.now. What's going on there? I mean, let's think about this for a second. Why do we even need the current time when I'm using a ticker? I wasn't using a ticker before. So what if we just made our own monotonic clock here? So let's just have R mono equal to 0. Block. It's gonna go. This is so dirty. This is just, oh man. I'm only reading, so I guess it's alright to write from this. So we'll increment the clock. We'll sleep. Or, I don't know. Do we even need to do that though? I mean, we're in the ticker. We can just increase that when it draws. We can just increase mono. That is crazy. What the heck is going on with time.now? That it's taken that much time. Like, all right. Now let's take a look at our stack trays. Okay, that looks much better. That looks much better. We're wasting all of our time on our trig functions. That's great. Of course, this is all relative, so we don't know what those times actually are. Let's go. Yeah, that's much better. All of our times in the go routine. This thunk one, that's that anonymous go routine. So main starts, we call this, we call draw inside of this. And a lot of time doing trick stuff. Donut 3D, and we are doing a bunch of stuff there, and we pull weight in our select, and that join is kind of slow. But it runs and it spins, and it's spinning pretty fast. 30 frames a second is pretty fast, assuming that it's right. Wonder if we can get 60 frames a second. Yes, that's pretty great. It may not show up in the stream, but that was 60 frames. There was a high fidelity Taurus spinning there. Okay, back that back down. 30 frames a second. So yeah, let's look and see what people are saying about time now. This is 2012. Yeah, maybe I'll look into that later. I mean, clearly using time. There's other options. I mean, the monotonic clock here works fine. Got a thing working. Let's get back at it. Oh, and theirs is running smoother because we're updating every tick. So we could slow ours down. Doesn't really matter. I'd be curious to see if we start this at 0.1 and then we just add it by half. Does it slow down by half? Nope. That's better. So now we got a nice smooth. Okay. All right. So a lighting and a frosting texture. We have to calculate normal vectors. Okay. Which direction a scene point or an object surface points. I love that they typed their Python too. I don't know what this is. I don't know my Greek alphabet. Epsilon. Okay. If can I go back in this? I think I can. Is this readable? Is an image? Okay. Thought it was actually an image. It doesn't matter. This is showing time.now. Go back again. Nope. That is, that's a PAL slow. I like to open that Chrome and take a screenshot of it. Anyways, it doesn't matter. It doesn't matter. Okay. SDF function. Normal takes a function, SDF, that takes free floats and returns a float. I don't think I remember how to do a go function type. As I stare at that, I'm just like, I don't remember. So you just need to put the var names in there. A triple. x equal to SDF function x plus epsilon yz minus SDF x minus epsilon y and z, those are the same thing. Y plus epsilon, y minus epsilon, z minus epsilon. Okay, so we have normals for x, y, and z. We know now not to use math.pow, so math.square root nx times nx ny times ny and z times return our slice float 64, sorry, our array, and I guess it doesn't matter. Slice. I don't know, torn. I don't know. We'll leave it like this. It's probably gonna bite me, and then I should be using the slice. Okay, so nx divided by norm and the our norm. So the function, we have x, y, and z. Those all get passed in. Too many arguments to call math.square root. Oops. What was the Python? Are they adding those? Yeah, they add all three of them together. Okay. We add all those together and return it. Then we're sampling. D is less than 0.01, so we hit the sphere. So we want to check the normals. Donut 3D TX so we ignore X normal can't even remember. Just go have the structuring, go the structuring. Oh, sure. Multiple return values. Gosh. Oh, man. This is so embarrassing. It's been so long. All of my go-isms are gone. All right, there we go. Okay. All right, so now we're returning. Yeah. Figure out if it's lit or if it's frosted. Switch. Pipe. Okay, case is frosted. The inverse Boolean stuff just breaks my brain when I read it. Return at if is lit else. Okay, so if it's frosted and it's lit, return an at sign. Case is frosted. Not lit. Return our octothorpe, as it is called. All right, if it's frosted, we do those two things. If it's not frosted, just gonna be explicit. Not frosted and lit. Not frosted, not lit. Alright, so equal sign if it's lit, otherwise a dot. Okay, no syntax errors. I'm super excited. I'm so excited. I'm so excited for a stupid ASCII donut in my terminal. Woo! And it does the thing. Heck yeah. We need to slow it down a little bit. That's awesome. All right. How do we slow it down? We go here at 0.05. Yeah. Ooh. It's glorious. It's beautiful. That's great. Did a thing. Let's see what it looks like in dark mode. Oh, that's so great. Yeah, I don't understand the normal stuff. Like I do and I don't. So we get the normal from the surface. We approximate the normal from the surface. Where did we say like where the light comes from? Yeah. I might have to spend some time on this one. It's just been too long since I've done anything mathy, but that's what I'm here for. That's what this is for. And that's so satisfying. I got this working too. Oh man. All right, how can I make a GIF on Windows? I mean, obviously I got the video we're taking right now, but there should be a way to just capture a GIF. I wonder if Windows has lice cap or flame shot. Choo-choo. I'll take lice cap. That'll work. Don't need a desktop icon. No, thank you. Lice cap is so great. If you've never seen it, it's so good. That's about what I wanted. Alright, so we got that ready to go. Eight frames per second. Just hit record. Okay. Oh my gosh, I know it's got to fill out all this. Desktop. Donut. Give me like 2 seconds of pre-roll. There we go. All right, cool. Got a GIF. Or a GIF. It's probably like 7,000 megabytes. Oh, that's not bad. 273 kilobytes. P. I'll take it. I will take it. All right. All this stuff. Because I profiled this. All right. We better check Brendan's repo. If Brendan's repo, if the license is good on this. Totally blind. Doesn't it tell you the license over here? Common Development Distribution License. I don't know what that means. Let's see. This is just a repeat. Where's just a summary? Weak copy left. Different sites here. Requires that derivative works. It doesn't matter. Just leave it out. I'm just going to commit my Go file. Actually. I should profile it again and compare though, and see what difference the tint was making. Good enough. Was there anything else I wanted to do? I finished that article. I think that's it. And it's good to end on a high note. So that's fantastic. It took 2 sessions, a little more than 2. So 2 full hours to work through that code. Me doing silly stuff, not being able to remember go, but getting a little better every time. Just slowly go back into it. It's like jumping into an icy pool, takes your breath away. So it's still great. I love doing the streaming. I think when I started the stream, I just said I was starting back at the second one today, but trying to get in the habit of saying like date and time, so I have that in the video. So it was Tuesday, January 10th, and it is now 10:30 p.m. So I'm done, and it is bedtime. But this was great. It was great to get something done, to see some progress, and get it captured. Get like the bugs captured, the debugging captured, the profiling, all the silly mistakes. But yeah, we'll do it again.